Tunneling is the process of encapsulating content from protocol A into another protocol B, usually because protocol A is blocked or unavailable. In this video, we'll explain how TCP tunneling works, and we're going to talk about the different applications of TCP tunneling. And finally, we're going to talk about pros and cons of TCP tunneling as usual in this channel. Speaking of this channel, guys, if you're new to this channel, welcome. My name is Hussein, and in this channel we discuss all sorts of software engineering by example. So if you want to become a better software engineer, consider subscribing and hit that like button. Let's just jump into the video, guys. So in order to talk about TCP tunneling, we really need to explain TCP in general in a very TLDR manner, and I'm gonna do that right now. But if you want to learn more detail, I put a course about TCP versus UDP. Check it out. It's a free course right on YouTube. It's like a 40-minute video explaining the difference between the two things. But that's it. TCP connection. Let's say I am a client that has an IP address C1, and I want to connect to a server S1 IP address, and it has an open port on 22. Okay, which is the SSH, the secure shell server. Okay. So in order to do that, I want to establish a bidirectional TCP connection. We talked about that in another video, but that's in a nutshell. It's a bidirectional. You can send, C1 can send data to S1, S1 can send data to C1, okay? So here's how it is essentially in a nutshell, right? You have a piece of data, let's go the data request. Let's say I want to make a SSH request and say ls, list the directories, right? This is an example of how the data will look like. Okay, and then you take that content, the string of list of byte, and then you say, okay, TCP, where is this going, right? You say, okay, this is going to S1, and this is layer 3, right? This is the network protocol. This is the IP. And then you say, okay, where is this coming from? It's coming from C1 IP, okay? So the red one is layer 3, okay? And then we add the port. Where is this going exactly, right? It's going to S1, but which application, which port, right? So yeah, it's going to port 22. This is layer 4, okay? TCP transmission. And this is coming from 8992. It's a random port because we really don't care about the client ports, right? Just put anything and then you just send it over, okay? Send it over, and then the client, the server processes the request, try to understand what is going on, and sends back a data response, right? This could be the list of directories in this folder, okay? And then what it does says, okay, I am going to send this, the destination is C1 now, okay? And it is coming from server S1, okay? This is going to port 8992, remember that we just flipped it literally, okay? And this is coming from port 22, and that's it. That's how TCP works in a nutshell, right? There's a lot of transmission and congestion control we don't really need to talk about, but this is in a nutshell how it works. There's a piece of data, it adds some headers to essentially control where is it going, okay? So what is TCP tunneling, right? TCP tunneling is essentially what we want to do is we want to connect to a destination, but for some reason the destination is unreachable, right? Directly from me, okay? It could be blocked by firewall, it could be like an internal network, could be anything, right? Right? It's just not reachable. So what you do is essentially you establish a normal TCP connection just like we did. Just you're going to establish C1 can see server 1 in this case. So it's going to establish a normal, legitimate SSH connection, right? TCP connection on port 22. It says, okay, but what it does is it does something sneaky. It says, you know what? For my data, okay, I really don't want to send an ls command. I really want to encapsulate another TCP packet inside that data. So let's explain that, okay? So what you do normally as a C1 here, as a client, you make your request normally. Get / right? I want to give me the index.html, right? And this request is addressed for S2. You make your request as if it's addressed to S2, okay? This is the TCP packet, okay? And this is going to port 80. That's the server that's running this thing, okay? And I want to get the index.html page, okay? And it's coming from me, C1, and this is my random port, 1234, okay? And here's the tricky part. Here's the interesting part. We take that TCP packet and shove it in as the data for my first connection. Okay, so data request is now another TCP packet. But guess what? We're not done yet, right? We take that data request, which is, by the way, a TCP packet, which has all that stuff. And then we say, okay, let's add our headers. This is going to S1. This is going to port 22. This is coming from C1. And this is coming from 8992. Guess what? This is another random port, right, guys? So if you send this over now, it is a completely legitimate request, right? This is just, we're sending this request, but the data portion here is kind of sneaky. And it's, by the way, it's encrypted because we're using secure shell. So nobody can actually see it if someone sniffed it, or even the firewall doesn't really know what's inside it. That's the cool part. Okay, so the firewall says, okay, you're going to port 22. Please proceed, sir. You have nothing to hide. Go in. And what we just did is essentially smuggling. We're smuggling data inside another package that is legitimate. So, okay, this one takes that data. I say, okay, data request. Let me look at this. Is it just an LS request? Is it really a CHON request? Is it a CD change directory? No, this thing is sneaky. Look at that. Decrypt and whoa, is this just another TCP connection? All right, what do you want me to do? This is a tunnel. We're going to create a tunnel. So go ahead and TCP, you know what you do. This is addressed to S2. S1 has full access to S2. It can establish a connection. It's a completely different network. So S2, this is going to port 80. And this is the request. This is the actual data that we're going to send, which is the GET request. But it is coming from C1. That's the bad thing here. We cannot send this just now. We need to change it. This needs to change to S1. So the server says, okay, this data is, by the way, it's coming from me. You and me, we go far back, right? So it's okay, S1 and S2, coolios. So they will send it, okay? So S1 will send that packet to S2. So S2 has no idea that this packet was coming from a C1, right? It has been smuggled right from somewhere, and it's coming there. Okay, it's like, yeah, this is the cartel essentially. Okay, and this is going on, and then the head of the cartel remains anonymous. Okay, so send in the request, that get back the request back, send back what? The index.html, because it's just, hey, as long as this as far as this is concerned, this is a request that's coming from S1. S1 just said, hey, give me index.html. Okay. And then you get the index.html, but guess what? Now we need to repackage this because it was the TCP packet was intended for me, S1. Now we really need to change it to send it back to C1, right? So change it to C1, remember the port, going to 1234, and then this is coming from you, S2. So, okay, so I'm going to change it to S2. You have to put this because the client actually requested S2, so we have to put S2 there, okay, as a from port or from IPN port, okay? And then this is getting smuggled again. As the data response, you smash the S1, C1, 8992, and then S122, right? This is coming from me, this is going to you, and then you send it over. Firewall is completely doesn't know what's going on, right? Oblivious. Is that a word? I think that's the right word there. It's an oblivious. He doesn't know anything going on. Okay, so send it over. Okay, and then the client receives data response. Okay, what is in it for me? Opens it up and says, oh, yep, that's what I want. That's an index.html. It's coming. Yeah, this is me. C1, that's me. Okay, this too is coming. Nice. And it got back the index.html. So that's how essentially a TCP tunneling works, guys. Okay, so here's the list of the applications of TCP tunneling. That's what we're gonna discuss now. Okay. So we learned about TCP tunneling. We know how it works. It's a tunnel. You send things, you smuggle data, the other party unpacks it, and then makes the request on your behalf. So there's a lot of TCP connection going. Keep that in mind. We're going to come to that. Application of TCP tunneling. let's say you have a blocked port. Okay, that's one application of where you can use TCP tunnel. So you have a client, right? You have a server running 3389. Usually 3389 is, by the way, is the remote desktop application, right? So where you can control a remote desktop. Okay, so the server is running this application, so 3389, and I want to connect to it. I want to remote control my server. Okay, why are you not allowing me? Because firewall just decided that, hey, sorry, you cannot go through 3389 for some reason, right? So you are behind a firewall, and the firewall is blocking any request going to 3389, and it can, right? Because it can see the TCP packet, right? It can see the port, it can see the IP, but it cannot see the data. It doesn't know what the data, if it's encrypted, if it's not encrypted. Of course, it can't see it, right? That's how firewalls play with that. It plays whatever. It really depends which layer it is. And guys, we talked about the OSI model, the layers, and I'm gonna reference it here. Go check it out. Okay, talk about that from a software engineer, because I'm a software engineer. I talk about things from a software engineering point of view. I try at least. Okay, so it's blocked. Okay, any request to 3389, B, done. Okay, how can I use tunneling to do that? We can use something called local port forwarding tunneling, okay, to do that. Okay, and by its name, we essentially create a local port on my client, okay, because that's what I want to do, right? I'm client, I want to connect to server 3389. That's my goal, right? What you do is essentially you create a local port, okay, and that local port will be your entry to the tunnel which will get you to that port. Okay, so let's talk about that. So here's what you're gonna do. You're gonna introduce a new server to do that. Okay, or if your server have the SSH or the port 22, okay, which is our vehicle of choice, the TCP vehicle of choice, which is the SSH. Okay, it could be the same server, it could be another server. Let's just put another server for simplicity. Okay, and then what you do is essentially you create your TCP connection, completely legitimate. Firewall allows it, allows 22, so it connects to that, connects to server 2, and then it allows the connection. And then here's what happens. When you create that, you say that, hey, by the way, create a local mini server on my machine running on port 8080. Okay, so this is a process running port 8080, and that is your entry to the tunnel. Okay, and then this port 8080, which is any number, right? You can pick any number, which is the local port we talked about, is the entrance to the tunnel. Okay, and that goes through that and links you to the 3389. And how does it do that? We just explained it. What any request to port localhost 8080 to yourself. So essentially what you do is you open a remote connection, you type localhost 8080, you kind of make a request to yourself, which is kind of silly, right? But what it does is that you make a request to yourself, 8080, the server says, oh, 8080, that's a request. All right, where is it going exactly? It looks like this 8080 is linked, right, through the tunnel to 3389. So this little process does the smuggling that we talked about. It takes the packet, packages it into a legitimate SSH request, put it there, put the port of the server 2. It just is the data as if it's going firewall. It just knows that it's going the server 2. That's what the firewall knows, and which forwards it nicely. Server 2 gets the data, says, let me open it up. Oops, it's a tunnel. It's part of the tunnel thing. It's some smuggled data. Opens it up. It says, okay, it looks like C1, which is the client, wants to connect to server 1 on port 3389. Let me establish a TCP connection. That's what you see here. Establish another TCP connection, forwards the data, gets back the results, which is like an image of a screenshot of whatever the state at, and then you send back the data, send it over, and then it gets back the result. Okay, and then this is the path essentially, just going up back and forth. Okay, so this is just a tunnel. The local port forwarding tunnel is just for one port. That's what's called local port forwarding. Okay, you have to create it for every port. Okay, so if I make a request for server 3, for example, on port 80, that doesn't go through this. You're making a request to server 3. It just goes through the firewall. Firewall allows 80. It just goes to the server 3. So I just want to explain that. So it does, because we're going to go through another example that actually makes a difference here. Okay, makes sense, guys? Another application of tunneling is it's like an internal IP. Okay, problem. I have an Node.js application, I have a Python Tornado application that is running locally and on my 192.168.1.8, which is a local IP, which you know, you cannot access from outside from the internet, right? We talked about that. Public IP versus private IP video. I'm going to reference it here. Go check it out, guys. So I'm explain why this is happening. Why cannot you access it? And then what happened here is if you give someone your IP and you want them to check your website that you just created, okay, they cannot, because what the heck is 192.168.1.8? It doesn't mean anything. Okay. We also talked in that video of a possible solution by allowing port forwarding in the router, which is a little bit dangerous. We saw that you can solve this by another approach, okay, which is called reverse port forwarding tunnel. We talked about local port forwarding tunnel, which you made me create a local server, a little bit of mini server on my machine, and people can I make requests to that and then goes to the server. Okay, so let's talk about that. I'm gonna talk about the difference between in a second now. Okay, so what do you do essentially? You do the same exact thing, but the only difference is the port that we talked about, the local port, is now on the server. So essentially you create the tunnel, but the tunnel is at the other side. Okay, so you create the tunnel or with that magic port number, which is linked to your IP address and 8080. Okay, so now external parties does not know you, right? They are given server 2 8888. Okay, so if someone makes a request to server 2 8888, which is public obviously, okay, they will be forwarded to you and they will get the request. Okay, it makes sense, guys? So let's talk about a little bit of local port forwarding and then the reverse port forwarding. What's the difference between them, so you can really understand. So here's the client, right? The client that makes the request doesn't know the destination server, which is me in this case, which is your server, your Node.js server. That's the reverse port forwarding, right? The client doesn't know the server. Okay, the local port forwarding, the server doesn't know the client. I am making a request, but the server does not know me. It doesn't have any clue that I am the one who made the request. Does that make sense, guys? Okay, so local, it's exactly like proxy versus reverse proxy, which I'm going to reverse here. Reverse. Yes, I'm going to reverse it here. Everything is going to reverse. My tongue is going to reverse now. Okay, so I'm going to reference the video proxy versus reverse proxy. It's actually, I explained the difference between proxy and reverse proxy. It's exactly almost like this, right? So it's almost like a proxy. You know that it's like a forward proxy. So the client, right, it knows the destination server, but the server doesn't know the client, right? While in the reverse forward, right, the reverse, right, the client doesn't know which server is going to end up with, right? It's going to make a request to this machine, which happened to forward it to that destination server. Make sense, guys? Okay, so we know about local port forwarding tunnel, we know the reverse port forwarding tunnel, and now let's talk about the third type of tunneling. Okay, you have a blocked website. You have an ISP that is just kind of blocking, I don't know, political site or something, right? It just doesn't want you to watch something, right? It's kind of hiding things, right? It doesn't want you to view certain sites, okay? So you want to go to blocksite.com and your ISP proxy says, hey, sorry, blocksite.com hosted on server 1 is blocked. And it can do that because it's an HTTP proxy, because it can look at the site, right? If it's a TCP proxy, it cannot do that, obviously, okay? Uh, well, it can do that from IP, but if the IP changes, it doesn't. How it doesn't know, right? So it has to be an HTTP proxy. Out of the topic, I'm sorry. Okay, but I just like to talk about different concepts that are related to each other, guys. Let me know if I'm getting out of the topic. I know it's like I talk a lot about it and then get derailed in the topic, but sometimes some people find this useful. Some people say, okay, you know what, this video could have been like 3 minutes and you made it 20 minutes, right? I don't know. This is just me. I just like to talk about different things that are related to each other, and just give you like some value. Right. All right. Side is blocked. All right. What do we do? Dynamic port tunneling. So we have local port forwarding, right? Tunneling, reverse port forwarding tunnel, and then dynamic port forwarding, always called SOX proxy. Okay. And here's the cool thing about that. What you do is you create essentially a proxy running on your machine or outside your machine. But here's what you do. You configure your laptop or machine to always go through that proxy. What does that mean? That means any network call you make, right, goes through that proxy, guys. Anything, right? Anything goes through that proxy. This is how Fiddler works, by the way, guys. If you're familiar with Fiddler, this which kind of captures your HTTP traffic. You run it. There is a proxy. Your traffic goes through the proxy and then just captures everything that goes, right? Okay. So what do? It's exactly like the local concept, right? So what you do here is you create a tunnel, and that tunnel goes to the other server, okay? Server 1. So you create a tunnel between server 2 and yourself, okay? But here's the cool thing. If you make a request to server 180, you don't make a request to localhost 8080 like the local. You make a request normally as if you're going to server 1, just normally. Your proxy internally, your network, well, essentially will forward it back to your local 8080, which is this tunneled SOX proxy, and then it says, okay, you want to go to server 180 port 80, okay, let me start smuggle you. You're gonna go smuggling route, right? So takes your request, package it up as an SSH request, send it over. As server 2 gets it, makes the request on your behalf. Server 1 gets back the results, and then obviously gets you the result. Okay. What if I make a request to server 33389? What happens? Does it also go through the? Yes, everything goes through the proxy, and that's the cool thing now. Now by just serving that, right, proxy, all the request goes through your tunnel. So if this is encrypted, if you want your ISP proxy to not know what you're doing, you can do that. And yeah, if you think about it, guys, this is similar to the VPN, right? It's just like you're going there, and then everything you're going is just go through this encrypted channel. So your ISP doesn't know where you're doing, right? So that's essentially another application of the VPN, virtual private network. So that's how it works. You make a request, goes there, and then that's it. The server 2 start making a TCP connection to server 3, right? So everything goes through that. Obviously, if this is a VPN, it's much more smarter than that. It will just shift the servers from one server to another server. Onion routing is another thing, right? Onion routing is another concept of tunneling, right? Where Tor, for example, just changes that will adds much more layers over another layer over another layer. All right, guys, we talked about tunneling. We talked about the application of tunneling. What's the good and what's the bad? As always in this channel, we have to explain the good and the bad and the ugly. All right, pros. Secure connection, right? If you don't want, if you're communicating over HTTP and you tunnel that, right, it will become secure. It's not going to be TLS, which is something we talked about here. I'm going to reference it. It's not going to be on TLS, but it is kind of encryption, which is you encrypted the data as a package of the SSH, right? The TCP tunneling, right? And access block site, I think that's an advantage, right? If your proxy kind of blocks you certain sites, you can just go through your own SOX proxy and just a VPN, and then avoid all of that stuff, right? Anonymity, kind of similar to VPN, right? Expose internal traffic, we talked about that, the reverse port forwarding, tunneling, right? So I have a website, and there's an example of this is actually servo.net. I'm going to reference it here. So maybe I show an example after this video. I should show you the servo.net, how can you actually host your own website using this essentially reverse tunneling, right? So you can expose your internal server to the outside. You can give someone a URL, and that URL will point to your server, essentially, right? It's through this reverse proxy concept. Cons, is there anything bad about this? TCP meltdown, TCP over TCP. You can imagine, guys, right? How many TCP connections we're creating, and TCP is not something fast because of how there is a congestion control, there is a guaranteed delivery, there's retransmission, there's checks, it checks a lot of stuff. And if you're doing a TCP over another TCP over another TCP connection, this thing can just shut down, right? Your client will keep waiting and waiting and waiting and waiting for minutes, maybe, just to get a response because of the slowdown of TCP, right? And then again, guys, check out the TCP versus UDP video if you want to learn more about the benefits of that stuff. Slow transmission, we're talking about that, right? So it's essentially slow in nature because of the congestion control, right? If there's a lot of packets going on, it's kind of hits the brake, and it doesn't want to become the 405 on 2 p.m. on a work day, right? So it just slows down, just like this traffic light, right, that you see when you enter a freeway. Stateful, it's a stateful protocol because you're using TCP. So if the server just restarts, you're kind of out of luck, right? You have to re-establish the connection again, right? That's why some people use the HTTP tunneling, which is hopefully another video. I'm going to make it once I can understand what it is exactly, because it's really complex compared to TCP, really. So that's why I like to take some time and just kind of do some research before I make a video. All right. No application logic. That's where HTTP tunneling is actually beneficial. Essentially, when you look at the TCP packet, you don't have any context of the data about the application. You know the port, but that's not enough, right? You can just make decision based on the port, but the port is not enough to tell you context about the application. Let's say we talked about the GET request, right, guys? If you make a GET request, okay, and that GET request, how do I know which URL you're going to? You don't, right? You cannot know that. I mean, the server tries to make sense of that, but if you're operating at the TCP level, you kind of don't know this. You just know this is data. This is an encrypted data, and that's it. Right? You don't really know what is in it. Okay, you cannot. It's really hard to do it because you don't have context. It's just it could be part of the GET request. It's not all of it because TCP just breaks things down, right, guys? All right, guys, that's it. You made it. If you made it, give it a like, guys, and really leave a comment. If you made it all the way there, that means you're really dedicated to becoming a better software engineer. Thank you so much. So let's summarize this thing. TCP tunneling, it's a smuggling protocol. That's what we do. That's it. Just you basically create a TCP connection, legit TCP connection, and you smuggle data in that, right, in that connection as something else. Like you put it on your shoes, or I don't know, right? Like that movie where you put stuff in your gut. I don't know. I forgot the movie name. Scarlett Johansson becomes limitless. No, I'm mixing two movies together. What's the movie? Remind me, guys. I forgot it. Yeah, where Scarlett Johansson become like this super woman. There's like she's so powerful. There's like a blue bag on her that get burst. All right. So TCP tunneling, smuggling. Okay, yeah, that's where we are. Applications, right? We talked about a lot of applications: blocking sites, reverse tunneling, forward tunneling. What the heck is forward tunneling? Local port forwarding. Okay, and then we talked about pros and cons. Thank you so much for making it all the way, guys. And if you really enjoyed this video, give it a like and subscribe for more content. Hit that bell so you get notified whenever I leave a new video. And with that said, thank you so much for checking out this channel and checking out this video. I'm gonna see you in the next one. You guys stay awesome. Goodbye.